All right, here we go. Last section of the chapter. This shouldn't really be anything new to you, all right? It's just rehashing some stuff that we've already done, just putting it together. What do you think of when you see this thing says coordinate geometry? What do you think of? What is that? Graphing. Okay, yep, absolutely, graphing. So what kind of stuff did we do when we graph things? We found points, ordered pairs. Then we did some stuff with that, with x's and y's. What kind of things did we find? Well, what kind of equations? Yeah, it's true. They are all linear. That's true. Remember, you had 2 points. You could find what? 3 things, right? Didn't we do 3 things? You could find the slope, right, of the 2 points. You could find the what? The distance between the 2 points, correct? What was the other one we did? Slope, distance. Yeah, midpoint. Yeah, find the midpoint. That's it. If you have a line segment, right, you can find the midpoint. So we had equations for all that stuff, right? You said equations. So we did have some equations. So let's review those briefly. So let's do slope first. Okay, so what is the equation for the slope of a line with coordinate geometry? We use the letter M to represent slope. Remember that? So do you remember what it is? Is it y equals? No, it's not y equals mx plus b. That's not the slope. I just want to find the m part of it. What do we do up here? That's right. We subtract the y's from each other. Now, we normally put y2 minus y1 because that's what books do, but it doesn't really matter, does it? As long as what? The x is in the same order, correct? All right, so I could have gone y1 minus y2, but on the bottom, I would have had to go x1 minus x2. But this is the way books usually do it. So that's the slope. That's one thing that you're going to have to know how to do for this. What was the other thing we did? Distance. Okay, let's do distance. So we had a little formula for that too, didn't we? D equals. What did we start off with? A big old what? Big old square root. Okay, and then we put a couple parentheses squared plus another parentheses squared. And what did we put inside those parentheses? Okay, is it plus or minus? It's minus. So it's x1 minus x2. Again, does not matter the order that you put them in. It really doesn't. It doesn't even matter if you mix up the order. But you got to make sure you just subtract the x's. Don't subtract an x and a y from each other. That you cannot do. Okay? And then you go y1 minus y2. So that's the distance formula. What was the third thing? The one that I forgot about? Midpoint. All right. Let me see. Are we even doing midpoint with this? We probably, yep. We're doing all 3. So this is good. So how do you find the midpoint? Well, what is a midpoint, by the way? It's not just a formula. It's a what? It's an ordered pair. All right, so I write it as an ordered pair. It's mid, so we're finding the middle. So how do we find the middle of something? We divide it by 2. And then now what do you do with the x's up here? Now do the x's first because it is an ordered pair, right? So it's important that you do the x's first. So it's x1 what? Plus x2. Okay, this is the one that has the plus. The others are just you subtract. This one you add. And so we did that to the x's. What are you going to do with the y's? Going to add those together, and there you go. So that's a little review for you, if you forgot. Is it all coming back? Yeah. All right, let's do some things with this. What do they ask you to do? Well, they give you a graph, and they put a parallelogram on this graph, and you got to tell me what kind of parallelogram is it, okay, with these points. So they're going to give you 4 points, A, B, C, and D. All right, so A is -1, 3. Point B is 3, 2. Point C is 4, -2. And point D is 0, -1. All right, so what we're going to do is plot all 4 of those points. And we're going to connect them, right? And we're going to have a quadrilateral. And we want to talk about that quadrilateral. What is it? Is it a parallelogram? Is it a trapezoid? Is it a, well, you know it's not going to be a triangle, right? Because it's there's 4 of them. But what's it going to be? All right, so let's do it. Negative 1, 3, negative 1, 1, 2, 3. Tell you what, this is going to be, yeah, let's just do it like that. No. Let's just make this a little bit bigger because they don't really spread these numbers out very much. So I'm going to make my graph a little bigger so it's a little easier. There we go. That's better. All right, now it's plotted. Negative 1, 3. Negative 1, 3. That's point A. 3, 2. 1, 2, 3, 1, 2. That's point B. Point C is 4, negative 2. 1, 2, 3, 4, 1, 2. That's C. And then D is 0, negative 1, which is right there. That's D. All right, so we got to figure out what kind of quadrilateral, specifically, as specific as you can, is what it says. What is this going to be? But the thing is, we're not just going to eyeball it. We're going to do a little math. Now, it looks like it's probably a parallelogram. Would you agree? But is that as specific as you can get? No, let's see if it's what? Well, does it look like a rectangle or a square? No, it doesn't look like that at all. All right, so what do you think this possibly could be? It looks like it could be a rhombus, right? How can I show that it's a rhombus? Using these points and using some math. All equal sides, that's right. Okay, if I can show all 4 sides equal to each other, okay, then it's a rhombus. But there's an easier way, because that's 4 things you'd have to do, and you got to put all 4 of them into to the distance formula, okay? But there's actually a little bit of an easier way. What else did we know about a rhombus? That you don't have to know that all 4 sides are equal to each other. What do we say? Let's talk diagonals. That could be a huge hint. Okay, let's talk diagonals. Okay, they bisect each other, but they bisect each other on any parallelogram, correct? They're what? They aren't equal to each other? It's true they're not equal to each other, but they're not equal to each other on a lot of parallelograms, correct? So look. Okay, well, but they bisect each other on every parallelogram. Okay, but are we going to use, how are we going to use these points to figure out what that angle is? We really can't, can we? Okay, we can't really find that angle right there with coordinate geometry. But what's one thing? We haven't talked about it in a little while, but just look at the 2 yellow lines right there. How do they intersect each other? Well, they do. They bisect each other, but again, they bisect each other on every parallelogram. Specifically on a rhombus, they're perpendicular, exactly right. So look, if they're perpendicular, I'm not even going to put the little rectangle there because I don't know just yet. I mean, it looks like it's perpendicular, doesn't it? Okay, but I don't know just yet. How can I show? Okay, doing math, doing coordinate geometry, doing some of this stuff right here. How do I show that they're perpendicular to each other? What do we know about 2 lines that are perpendicular? We know something about their... No, they're not equal to each other. It's something up here. We forgot already? They don't have the same slope. They have the what? Close. The negative reciprocal. Very good. See, now it's starting to come back. You remember all this stuff we talked about? Okay. So those 2 yellow ones right there, and I'll do the math in yellow. If they have negative reciprocal slopes to each other, then they're perpendicular. If those diagonals are perpendicular, then this red thing is a what? Well, not just a parallelogram. It's a rhombus, okay? Because on every parallelogram, the diagonals are not. Okay? Only when that parallelogram is a rhombus are the diagonals perpendicular. Does that make sense? So again, just saying it's a parallelogram, that's not specific enough. All right, this is more specific than just an ordinary, regular, everyday parallelogram. Okay, this is more specific because it looks like This is perpendicular, doesn't it? So let's show that it is. So let's do AC. What are we going to find with AC? We're going to find the slope of AC, correct? So let's do that. A and C. So I'm using this one and this one. What are the y's? 3 minus what? -2. See what I'm doing? I'm doing AC. I'm doing these two right here. So I take the y's and I subtract them. Doesn't matter what order you subtract them in. I'm just going to go this first one minus the second one. 3 minus -2. Now what do I subtract? Well, I subtracted the y's, and now what do I subtract? The x's, right. So what is it? It's -1 minus 4. And let's figure that out. What's that? It's 3 plus, which is a 5. This is a what? -5. What does that equal to? -1. So the slope of this one right here, AC, is -1. Now, what should the slope of BD be equal to if they're perpendicular to each other? Be +1. That's right. Okay? Because the reciprocal of 1 is just 1, right? But then you do the negative of it, or the opposite sign, to be a +1. So now let's do the slope of BD. All right, so here's B and here's D. Let's subtract the what? The y's. 2 minus -1, correct? So I'm doing these two now. 2 minus -1, and then 3 minus 0. 2 minus -1 is 3 over 3 is 1. Look at that. I got the slope of this one is -1. I got the slope of this one is +1. What must be true about those two lines? They must be perpendicular to each other, correct? All right. If they're perpendicular to each other and they are diagonals of a quadrilateral, then what kind of quadrilateral is this thing? This is now a rhombus. And we showed. Okay, we showed that this thing is absolutely a rhombus. You could have done it another way, but it would have been 2 more steps, right? And plus, finding the slope mathematically is pretty simple. What are the other ways that we could have shown that this was a rhombus? I could have shown that all 4 sides are equal, correct? All right? But I would have had to do distance formula for AB, then again for BC, then for CD, then for DA. That would have been 4 things, and each one of those would take longer than just doing one of these. Agreed? So you could have done that, and that would have been fine, and you could have said that it was a rhombus because all 4 sides were equal to each other. But it's a lot easier just looking at the diagonals and saying, oh, if the diagonals are perpendicular, yeah, that makes it a rhombus. We good? All right, let's do another one. That was kind of fun, right? Okay. I did 2 other things with this, but I don't think they're necessary. Oh, I know what I did. What if the lengths of these diagonals were actually equal to each other? Then well, right, but what if they were equal to each other? What kind of figure would this quadrilateral be? It'd be a rectangle, wouldn't it? Okay. So it could be a rectangle, it could be a square, right? But I mean, I hate to say this, but I mean, looking at it, it's obviously not a rectangle. But you could always do this. You could find the slope of AB and the slope of AD, and if they are not negative reciprocals of each other, then it does not form a right angle. You with me on that? All right, so you could, because somebody might look at it and say, oh, that's a square, all right? You're like, well, that's not a square because that's not a right angle. Well, how do you know that's not a right angle? Just by looking at it? Is that a good way to do it? No. Just see that the slope of this, we could just count. We could have done that right here too with the yellow ones. But look, since I got graph paper and I got it on here, let's find the slope of AB. Rise what? 1 and run what? 1, 2, 3, 4. So I went up 1 to the left 4. So what's the slope of AB? It's -1/4, isn't it? Went up 1 to the left 4, correct? All right, what about AD? Let's find AD. If they were negative reciprocals of each other, so if the slope of this If the slope of this was 4, right, then they would be right. It would be a right angle, and it might be a rectangle or a square, correct? Let's just find it. So let's count. 1, 2, 3, 4. That's down, though, because it's negative, correct? Over what? 1. So that's negative 4. Are they negative reciprocals? No, they're reciprocals, but they're not negative reciprocals. They're both negative slopes. So are they perpendicular? No, they're not. Make sense? All right. But we're good enough just showing that the diagonals were perpendicular. So now I could put a little right angle symbol there, couldn't I? Because I showed that they are perpendicular. Enough of that. Let's move on. Let's do another one. You ready? So that was kind of fun, right? Using some of that stuff that we learned before. Okay. I'm going to write this down. Because if I just say it, you're just going to forget. It says find the coordinates of f and g. So find, instead of saying the coordinates, I'm just going to say find f and g. Is that all right? So I'm finding these 2 points. That's a point, right? And this is a point. Everybody got it? Okay. So find f and g if the diagonals, if the diagonals of parallelogram, so they do tell you this is a parallelogram, EFGH, intersect at point T, and they tell you point T is 3, 2. You're like, what in the world is going on here? Well, let's put something in here. What's the first thing we could do? 3, 2, right. So 1, 2, 3, 1, 2. What point is that? Point T. All right, the problem says, find f and g if the diagonals of this parallelogram intersect right here. Do they give you anything else? I think they give you, I think they tell you E and H. Somebody got their book open? Look at example 2. Did they give you point E and point H? Point E is what, 0, 0? And they give that to you, correct? Yeah. So they give you point E, and they give you point H. Where's point H? Right there. Do you have to find it, or they give it to you? I think they give it to you. Let me get the book open. They give it to you, right? Yeah, that's what I thought. Because in my notes, it was hard to tell if I actually found it myself or if they gave it to us. So let me just double check, make sure I know what I'm talking about. Example, what, 2? Oh, sure enough, they do. Yep. Okay. And they even give you a picture and everything, don't they? So that was nice. Yeah, I wasn't sure how much they gave you on that. So that's H. So here's EH, right? And they tell you some other things, don't they? So watch this. If this is a parallelogram, and this is where the diagonals bisect each other, yeah, so let's do this. So watch. Oops. Let's draw the diagonals. So watch. This is where they intersect, right? And they intersect at the midpoint, don't they? If it was a parallelogram, everybody listening? Don't lose me, okay? Just because I'm sitting here thinking about it for a minute. So if this is the midpoint, because remember the diagonals bisect each other on a parallelogram, correct? And if they intersect at T, that means from here to here would be the midpoint, correct? So where's the other end? It's right there, isn't it? Would you agree? Okay, so that's my diagonal, correct? All right. What about going the other way? What about going from here to there? How did I get from there to there? I did what? I went up 2 and to the right 3. So guess what I'm going to do to get to the other point? I'm going to go what? Up 2 and 1, 2, 3. And that's where that diagonal will be. What's important about that? That's where the endpoints, that's where my other sides to this parallelogram are going to be, aren't they? Here, let's make this. Because remember, these 2 red ones are my diagonals. Everybody got me? Okay? This is the diagonal. This is where they intersect. So this is the halfway point of this diagonal, right? So if this is one of my endpoints, from here to here is halfway, how do I find the other half? Right, I went up 1 over 1, right? So I'm going to go up 1 over 1 there. Agreed? So same thing with the E and the T. How did I get from E to T? I went up 2 over 3, right? So how am I going to get to my other endpoint? I'm going to go up 2 over 3. Everybody see that? All right. So that means I can draw that. I can draw this. And then I can draw this. Kind of reverse my color scheme on this one than I did on the other one, didn't I? Does that make sense? Okay. So now if you have graph paper, it works out really nice and easy. All right. They actually find the midpoint. They do some coordinate geometry at the midpoint. But if you have graph paper, this is a good way to do it, I think. So where is this point right here? 1, 2, 3, 4, 5, 6, right? 6, and then what? 1, 2, 3, 4. So this point is 6, 4. What's this point right here? 1, 2, 1, 2, 3. So that's at 2, 3. Right, and this is 0, 0. And this is 4, 1. Okay, everybody got that? So, what's your F and your G? Because it says parallelogram EFGH. So, it would be what? E, if this is the H, which one is the F? Right, this would be the F, and this would be the G. So that's one way to do it. It might be the easier way. It's the less math way. If you have graph paper, right? If you don't have graph paper, you may not know exactly where these things are, okay? Unless you're really, really careful on drawing these and putting the right, making sure your spaces are evenly spaced and all that. But if you have graph paper, it's kind of easy. But you could have found that 2, 3 by doing this. Everybody watch. This is what they do. I'm going to make it a little smaller. And let's move all this just to the left. Give myself some room to write. So watch. This is what they do. Let's do it in white. So they tell you point T. What is point T? It's the midpoint, right? And where is it? 1, 2, 3, 2. So that's the midpoint. Agreed? That's point T. They tell you point H, don't they? Oops. I'll put the H right here. They tell you point H, which is 4, 1. So now we want to find this point right there. Let's say we didn't graph it, okay? Maybe we did a little rough graph to it, okay? We weren't real careful with it, so it could have been anywhere around this area, all right? So that's what I want to find. I want to find F, correct? We'll just call it X and Y. So check this out. Remember what the midpoint formula is? Okay. Equals Y2 I'm sorry. I was going slope. Midpoint is this. Yep, it's x1 plus x2, and this is y1 plus y2. But the problem is, it's not a problem. It's actually a good thing. They tell you the midpoint, don't they? So watch very carefully. This is it, okay? They tell you the midpoint. So what does the midpoint equal? 3, 2. Right? And they tell you a couple of these other things. Look, they tell you the two x's. One of the x's is just x. What's the other x? It's 4. So I could just call this, well, not 4. Now, what do I do to the 2 points? No, I don't. Look, what did I do? What do I do to the x's? I add them together. See that? That's the midpoint formula. So now, what can I do with the y's? Add those together. So what am I going to do that? It's not 2. It's right. You could go 1 plus y. I think it's easier to just go y plus 1. Does this make sense to you? Okay, so they give you one of the points, they give you the midpoints, or they give you one of the endpoints, they give you a midpoint, you're trying to find the other endpoint. So this is how I set it up. Now watch, you're going to find out that you're going to get that 0.23, which is kind of cool. Everybody look. So what is the x plus 4 over 2 equal to? What is this equal to? It's 3, good. Because this is the first part of the midpoint, this is the first part of the midpoint, and they're equal to each other, correct? So I could write it like this. X plus 4 over 2 equals what? 3. Before I do the math, let's set the other one up. Let's solve for y. What would I do with this one? What's that equal to? It's 2. All right, so y plus 1 over 2 equals what? This 2 right here. Everybody see that? Look, that x equals the 3. This y stuff equals the 2. And that's what I did. And now I can do some math. What do I want to get rid of here? First. Got to get rid of 2 things, the 4 and the 2. What do I get rid of first? The 2. Always get rid of what's being divided by everything, okay? So how do I get rid of something that's being divided? Multiply it by 2. So if I multiply it by 2 over here, it cancels out. What do I have to do here? Multiply that by 2. So I got x plus 4 equals 6. To subtract 4 from both sides, x is what? 2. Let's do the same thing here. How do I get rid of this 2? Multiply both sides by 2. That'll cancel. Y plus 1 equals 4. Subtract 1 from both sides. Y is 3. So what's the end point? What is point F? It's 2, 3, just like we said it was when we did the graph. Isn't that cool? So we did this mathematically over here. This, we did it graphically. All right? And they match up, don't they? Okay, they give you the same thing. If they didn't, we'd be in trouble. But they do. All right? So that's kind of cool. How would I find point G? Do the same thing, except we're not using the 4, 1 this time. We're going to be using the what? The 0, 0. All right, so if you want to try that on your own, you can do that. All right? And then there you go. Okay, one more. This is 10 after, right, this class? Okay. All right. What? Can't hear you. Yes, write a pass. All right, so example 3. Here we go. Whoopsie daisy. It says find the missing coordinates. So here's how they start you off. You got an x and y axis. I'm not going to do this on graph paper because they don't really need graph paper to do this. But I do need a graph. So that's what we got right here. Now, this is a little bit different. So if you thought, if you thought that was different, the stuff we did before, just wait till we do this one. And wait till I write this pass out. All right. Hurry back. All right. They tell you it's a rhombus, JKLM, and they tell you the lengths of the diagonals. Okay. And so let's put some stuff in here. Let's go red this time. I think I like the thing being red. So this is K. This is M. It's the same distance as K is, but it goes down. Then J is out here like this. And then L is out here like this. Alrighty? And they tell you that this coordinate at point L is W0. I'm sorry. Did they tell you that? Let me see in the book. Again, I don't... Yeah, they do. They put W0. Good. And that's it. Correct. But they do tell you this. They give you some information. What did I say? They tell you the diagonals have a length of 2W and 2T. What in the world is that? Okay, so the diagonals... They make you think on these, okay? This is the last section in the chapter, okay? They're really making you think on this. All right, so what I'm going to do is this. Let's draw my rhombus, okay? Because they do tell you it's a rhombus. This might not be drawn perfectly accurate, but that's pretty close. Pretty close. Yeah, that looks good. Okay? Now check this out. The diagonals are 2W and 2T. So look at the diagonals. The diagonals on this are along the y-axis and the x-axis, aren't they? Right? If I went from one corner to another, I'm following along this x-axis, yes? Okay? So that means what? Where is J? What is the coordinate of J? Now look, how far did I go to get from the origin to L? How far did I go? Well, now give me not a number, because it's really not a number. It's W. How far did I go over? That W could represent any number, couldn't it? 3, 5, 10, 100, whatever. Okay, so how far did I go over here? I went over W, didn't I? That's how far, whatever number that represents. How far would I have to go over to J? Right, I go negative W, good. You see that? It's the same distance. So what's my ordered pair going to be right here? Negative W what? Not negative WW, I didn't go up anywhere. I went 0, right, so that would be negative W0. You with me? Again, what does W represent? Just a number, right? I could have put a 5 in there. If I said this point was 5, 0, well, excuse me, what would this point be? Negative 5, 0. Okay? So don't get hung up on the fact that it's a W. Is the diagonal 2W now? Yeah. From there to there is the diagonal, isn't it? Of that rhombus, and that's 2W. This is W, this is W. Probably shouldn't have put a negative right there. The length of that is W, okay? But the actual coordinate would be what? Negative W. Let's think the same thing for the K and the M. Now, you should have a kind of an idea. Again, what does it say? The diagonals are what? 2W, that's that one diagonal. What's the other diagonal? 2T. So if from here to here is 2T, what is it from here to here? It's just T. And what is it from here to here? That's also just T. You with me? So that's how far up we went. What does the T represent? Just represents a number, right? I could go up 3, could go up 7, could go up 100, whatever. Okay? So what is the ordered pair right here? This point right here. How far did we go up? We went up T. All right, so let's say we went up 7. All right, so what would that be? Would it be 7, 0? It'd be 0, 7. But it's not a 7. What is it? It's a t. So what's the ordered pair? 0, t. And now you should be able to do this one. Where is this point going to be? Well, it's going to be 0, right? Because you don't go anywhere on the x. And you go what? Down t, so it's negative t. And that's what they wanted. So that's one of your answers. That's one of your answers. And this is one of your answers. That's what they asked for. What do you think? It's kind of weird, right? But if you understand, right, and you've understood since Algebra 1 that they put letters in for numbers, right? And it's exactly the same thing. If I put numbers here, you probably would have got that really quick. But just the fact that you put letters in there instead of numbers, it is kind of weird, but that's okay. It can be weird. We good? All right. There's one more example. There's part B to this. This was part A. There is a part B. You got a couple options here for part B because I don't have enough time. Class is about to end. So you could just look in the book, right, and try to figure it out. Or what's another way that I could teach it to you? You could go to last year's video and see if I put it on last year's video, okay? I have the past 2 years that I taught geometry are on there. So if I didn't do it last year, I might have done it the year before, okay? But I probably did. Make sure you look at the honors. Don't look at the CP. I kind of doubt I do this for CP, all right? But for honors, I usually do. So make sure you look at that. And I didn't write down the homework. What is the homework?
1 through 7.
Just 1 through 7? That's all I gave you?
Yeah. And then, but it's A and B.
What's today? Thursday, right?
Yeah, but you didn't say it was homework.
Right. Let's do as much as you can with 1 through 7. That's the part A. And then the part B is 21 to 26. That's not many. Let's do them all. So let's go 1 to 7 and 21 to 26. Okay, so let's do them all. We won't call it A or B. We'll just call it 6, 6, and that's it. Okay? That's not too many, is it? That's 6 problems, 7 problems, 13 problems. Yeah, that's not too bad. Go ahead. So 1 to 7, 21 to 26.